my screen. I was talking to somebody after the last class, and oh, before I do like work thing, how cute is that? They're here visiting,
Huh?
so that's why I've been slower with replying to emails. They came in for the weekend and they came early, so uh, I was talking to somebody last class who said they had a hard time in Blackboard because when they used Blackboard with their phone, they didn't have all of the toolbars. And so I showed them that I know exactly what they mean because I struggled with it the first couple of times that I tried to use Blackboard on my phone because I couldn't see any of the toolbars. And so we went through and I showed them what a student showed me as to how to do it. And both of us thought, well, maybe this is something we should show everybody just in case anybody else is having a problem. So I am not ignoring you people. I am multitasking, which I don't do well because I'm old. So can you guys see my phone? And as you look at my phone on Blackboard, that toolbar on the side where there's like the email and everything, you just don't see it. But if you look real carefully on the right hand, take that back, on the left hand side over here, there's a real skinny blue line. And if I run my finger down that blue line, eventually there's an arrow. If I hit it in the right place, that toolbar pops out. And so while the first couple of times, well, probably the first month or two when I was trying to use my phone to access things, I thought, oh my gosh, I don't hear the full functionality of Blackboard on my phone. But it's just because with a phone screen, you have that limited real estate, right? You have to kind of just play around to find where that arrow is to slide it over to get to that toolbar. So if anybody else has been wondering where that toolbar is when you try to access Blackboard on their phone, it is there. It's just hiding. So today we are going to look at more probability. We're going to look at probability with permutations and combinations. Homework 9, which is the assignment that deals with, I believe, just the basic definition of probability, is to be, no, I think that, yeah, is to be done by Tuesday the 13th. Homework 10, which is the probability with permutations and combinations, and homework 11, which is the not and or with probability, I'm sorry, not or odds with probability, is to be done by a week from today, the 15th. Before we get started looking at that probability with permutations and combinations, does anybody want to look at any homework problems at all?
Yeah, there was I think number 4 that I was
In
struck.
in which assignment?
The one for the 6, or the one that's due uh on Tuesday,
One for the 13th?
I think the one that's due today.
There's none due today, so let's look at the
Or
one
the
that,
one that was due Tuesday, I believe. Because there was a question that I couldn't figure it out on my calculator either.
okay. Well, you're supposed to figure them out pencil and paper and get them all set up and then do it with a calculator. So this asks you to find 10 combinations.
Actually, no, it wasn't this one.
Okay.
It was um maybe 11. I think it was. It was like that one, but it was like one minus, and then it showed something like two other
Oh,
things.
I know what you're talking about. I
Okay,
think I read about that one too.
Okay, let's look at it.
It was like this, but it showed 1 minus.
Yeah,
I believe it was. I know it was like 13, or it was before this one.
before this one?
Yeah, it was before this one. I want to say it was like 10. Or,
How's that look?
oh, no, yeah, this one. This one was the one.
All right. So what we've got is one, whoops. I need to turn my pen on, sorry. We've got 1 minus 12p11 over 13p12. So that's, if you wanted to, you could use your calculator to figure out that 12p11 and that 13p12. But I'm not sure if it does overload or not. And since these are permutations and not combinations, I'm going to take the time to draw it out if you don't mind. 12p11 means I'm going to 11 numbers starting with 12. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. I think that's 11 of them. 13p12 is 12 numbers starting with 13. So far, so good.
Yeah.
Now, everything cancels, and I'm left with 1 over 13. And then what you have to remember is in order to subtract with fractions, you need a common denominator. That 1, if I think of it as 1 over 1, the common denominator would be 13. So I can think of that as 13 over 13 minus 1 over 13. So my final answer is 12 13ths. Any better?
So I was getting a decimal, like 0.92.
Yeah, you'll get a decimal, but the problem is they don't want a decimal in a fraction. So let me, give me a second. I did have a calculator on this desktop. Here it is. I'm going to take my calculator and I'm going to take 12 divided by 13, and I get 0.923076923. I'm going to see, I'm going to press my calculator second, FD, and yeah, the calculator will take that decimal and turn it into a fraction for you. If I remember correctly, you're using a graphing calculator? Yes?
No, I got a scientific calculator.
Okay, on your calculator, if it looks at all like mine, if you press the second button and then kind of the next button diagonally to the right below, above the probability PRB button, on my calculator, there's uppercase F and uppercase D with a double-headed arrow in between it. Do you see that on your calculator?
Yeah.
Okay, that double-headed arrow, FD, turns a fraction into a decimal or a decimal into a fraction. And so when you've got that decimal in your display and you don't want to do the pencil and paper work to try to turn it into a fraction, you can see if your calculator will turn that fraction for you. So with the decimals on, like is your last answer, you're going to press second, then you're going to press that button, then you're going to press enter. And if you have we had a fraction, it'll change it to a decimal. But if you have a decimal, it'll try to change it into a fraction.
Well,
It doesn't every fraction, but it does quite a few.
well, that helps because I never knew you could do that on a calculated
Yeah.
turn fraction.
Yeah. Although
Does help. I didn't know that either.
say it again.
I was just saying that that does help. I didn't know that the calculators could do that either.
Okay. All right. Just ask. But I think doing, I mean, I did a lot of scribbling here, but I don't think I did any heavy lifting mentally arithmetic wise to do it by hand. Are you guys all right with doing it by hand way? If all else fail?
Yeah.
Yeah, but you'd rather do it by calculator again. So, all right, any other questions? Can I hear this one?
Yeah, this was the only one I kind of struggled on.
Anybody else want to look at any more of these? Have I waited long enough? I think my family knows a famous quote that I have is, patience is a virtue I do not possess. And so I always worry that I don't wait long enough. And I see if you guys have questions. So picking up from where we left off, what we've said so far is the probability of an event is equal to the number of ways the event can occur over the number of outcomes in the sample space. And so when we look at the number of ways the event can occur and the number of outcomes in the sample space, we have to count. We have to figure out how many ways can that be done. And in order to, we have the fundamental counting principle, which says that loosely, if I'm looking for M and N, that word and tells me to multiply. We're going to use the fundamental counting principle when things can repeat and you can get the same answer over and over again, which is something that our permutations and combinations don't allow us to do. We have permutations, and we're going to use permutations when the objects are distinct. Each one is different. DIS, how do you spell distinct, you guys? D-I-S-T-I-N-C-T, does that look better? When we can't repeat, and when order, how do you spell repeat? Oh my heavens, and when order matters. As opposed to, we'll use combinations if the objects are distinct, if we can't repeat the same thing over and over and over again, but order does not matter. And I believe that assignment, the questions where you kind of had to decide in order to evaluate them, if it was a permutation, a combination, or the counting principle. Additionally, I think in terms of probability, we said that the sum of the outcomes for a singleton outcomes for any event is 1. And the other thing that's important to remember is your answer for probability will always be a number between 0 and 1. So your answer for probability is always a fraction, as opposed to if a question says how many, our answer should be a counting number. And so when I approach these problems, I first see, is it a how many question? Should I get a whole number per answer? Or is it a what's the probability question? And I'll get a fraction for the answer. Second thing I see, I ask myself, does order matter? If order does not matter, I'm going to pull out my combinations. If order does matter, I'm going to either pull out my permutations or use that idea of visually creating the line for me and figuring out how many possibilities I have each. I'm guessing that this quick overview is probably about as clear as mud. So let's look at some examples. And this is where I have to apologize. My old lady memory is getting in the way. Did we start this sheet with the different batting orders last class? Is this
I don't know.
think so.
okay? I didn't think we got to it. I know I did it with the other section, and I had vaguely remembered that we hadn't started it with your class, but I trust your memories better than mine. So the question says there are 11 girls on a softball team. Amy, Beth, Chris, Steph, Al, Fran, Jen, Helen, Izzy, Jill, and Katie. And so they're distinct objects. Everybody's different. The coach needs to pick 9 of the girls to bat in the next game. Part A says, in how many ways? And so is everybody all right that how many ways tells me my answer is going to be a whole number? Can he pick the batting order? That word order tells me that order matters for the next game. Everybody with me so far?
Yeah.
Okay, since it's a whole number and order matters, does it make sense? I'm going to use permutations. How many girls are there to pick from?
9.
11.
11.
There are 11 to pick from, and we're choosing 9. So 11 pick 9. And this one time I'm going to pick 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces, starting with 11. And I could multiply that all out, but I know sometimes, does anybody else with the inexpensive scientific calculators, does anybody else have a problem where sometimes you pressed the button, but it didn't register? It's like I didn't press hard enough or something like that. And so I look at my answer and I say, I know that's wrong. And I look up and see that it didn't register everything that I typed into it. Oh my heavens. Are you guys getting a huge answer for this one?
Yeah.
So what, just short of 20 million ways of making the batting order. Okay, a silly aside, I made up this question because my kids played Little League for way too many years. My standing joke is, of those 20 million different batting orders, none of them will ever make all of the parents happy. So, all right. Next question says, what's the probability that Amy will bat third? And so over here, because I'm got a probability, I'm going to look for a fraction. Everybody all right with that? So the probability would be the number of ways that we can have Amy third over the total number of orders. And with a lot of these questions, for that total number of orders, if you want to, you could just fill in this preceding answer down below. But that, I think in my mind, in terms of reducing the fraction, the numbers are going to be too big, and I just think it's mentally too much heavy lifting for me. So that's why I'm going to rewrite this as the product: 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. No, I don't need the 2. I went too far. Sorry about that, folks. And when I think of the permutation that would be in the top, I know it's the permutation because we decided order makers. I could go through and use the permutation notation to get it. But with ones like this, as silly as it seems, I think that the idea of filling in the blanks makes it a little bit easier. Can you picture that, those blanks as being the line that the kids have to stand into bat? And what we're concerned is we want Amy to be third. So I'm going to go over to this third spot. How many Amy's are there?
1.
1. So there's one person available for that third spot. And the other spots, I don't care. And so after Amy's used up, doesn't that leave me with 10, then 9, then 8, then 7, then 6, then 5, then 4, then 3? Does that make sense? And now, the reason I leave it factored is rather than multiplying, getting two big numbers and then trying to reduce the fraction, you see in factored form, it's real easy to reduce. And it tells me it's 1 out of 11. If you don't want to leave it in factored form and you want to fully use that permutation notation, the denominator is our 11p9. In the numerator, there's one Amy, and we want to pick her 1p1. Then of the 10 remaining players, we need 8. So we want Amy and 8 more. So it would be 1p1 times 10p8. So which way do you folks like it better, with the permutation notation or that idea of filling in the slots?
I don't know.
Well, let's look at the next one. The next one says, what's the probability? And so in my mind, I see that word probability and I highlight it. I think, okay, this is going to be a fraction. That Beth will be last, Amy will be first, Chris will be fourth. Since it's a probability, my denominator is my sample space, that 11p9. And again, I personally like that filling in this blanks way, so I'm going to do it that way first. Then we'll go back and we'll look at it using permutation notation. And so I've got my 9 spots, 1, 2, 3, 4, 5, 6, 7, 8, 9. Beth is last. There's one Beth for that last place. Katie's first. There's one Katie for that first place. And Chris is fourth. There's one Chris for that fourth place. I've used up 3 of my team. And so now I have 8, then 7, then 6, then 5, then 4, then 3 ways of picking the next players. The 8, 7, 6, 5, 4, and 3 are common factors. In the numerator, it multiplies to 1, and the denominator, it multiplies to 990. Huh. Is that doable?
Yeah.
Instead, if you want to do it just calculator based with your permutations, what we've got is 1 Beth and 1 Katie and 1 Chris. And from the 8 remaining players, we need 6. Out of from the 11 on the team, we need 9. And both should give you the same results. However, if you do this one, when it comes to reducing the fraction, I'm not sure that the calculator would do that reduction for you. You would have to reduce the large numbers by hand.
I think it's easier doing it the first way.
Well, I hope I'm not strong arming you. I like the first way better. However, the second way, if you're using the MyMathLab, you pick that Help Me Solve. I think Help Me Solve is probably going to show you the second way. Should we look at question number 2? Question number 2 says there are 7 girls and 5 boys in a class. The teacher wants to pick a group of 6 to work together on a project for the class. Okay, if I'm picking a group, even from class today, if I were to try to pick a group of students to work together on a problem or a project, would the order matter? If I'm picking a group of people, would you working with me be different than me working with you?
No.
No. So order does not matter. And so if order does not matter, should I use my P's or my C's? I couldn't hear exactly what you said, but if order doesn't matter, that's your combination. I have to apologize because I had typed this sheet out myself. It's chock full of typos, and every semester I just reinserted thinking, oh, I fixed those last year, and then I look at it and I think, damn it, I didn't. This shouldn't be how, this should be how many. And so I'm going to expect a whole number here. I want groups of 6. Order doesn't matter, so I'm saying it's a combination. How many students are there to pick from? Total in the class?
12.
12. And how many of them am I choosing?
6.
6. So 12 combination 6. Those of you who use a calculator, how much, what is it?
924.
924. I'm taking your word for it. What I was going to do, because if I thought I remembered somebody who had a calculator without that button. The 6 tells me the denominator 6 factorial. The 12 tells me I want the same number of factors starting with 12 in the numerator. And let's see, the 6 in the, oh, you know what? Yeah, the 6 and the 2 cancel the 12. 5 goes into 10 twice. 4 goes into 8 twice. 3 goes into 9 3 times. So that's 44 times 21, which is that 924. So both ways we're getting it. Part B says how many ways, so we're looking at a whole number. Can a teacher select a group of 6? So it's a combination, and we're selecting 6. But I only want girls. If I only want the girls, how many do I have to choose from?
7.
7. And 7 combination 6 turns out to be 7. If anybody's wondering how I got that so quickly, remember we said there was that shortcut. 7 combination 6 should be the same as 7 combination 1. Next one says how many ways. So again, I'm expecting a whole number. Can the teacher select a group of 6? It's a group, it's still a combination. I want to choose 6. Only boys. If I'm only picking boys, how many do I have to pick from?
5.
5. And if I put that in my calculator, I guarantee that's going to tell me that it's an error because the first number is smaller than the second, which kind of is like saying, hey, wait a minute. If I only have 5 boys, is there any way of getting 6 boys out of that class? No, it's not possible. So this is going to be 0. And if something's not possible, we will get 0. Next one, again, it's how many ways. So I'm expecting a whole number answer. I want a group of 6. This time my group of 6, I want 4 girls and 2 boys. So that word and tells me I'm going to be multiplying. Because I'm making 2 different selections, I'm going to have 2 combinations. I want 4 girls. I have 7 to choose from. I want 2 boys. I have 5 to choose from. I think there were some questions in the combinations that people emailed me last evening where it was this type of thing. you're looking for a group of so many, but you want some from each different category. Does it make sense if I want some girls and some boys? I need a separate combination for each of them. I need a combination for the number of girls I want. I need a combination for the number of boys I want. Now,
And that would
do
be,
it fast. Go ahead.
would that be 350?
Right. The first number is 35. The second number is 10. So that gives me 350. Next part, it's all probability. So these should all be fractions. What's the probability that I get 6 girls? Well, if I think about that probability fraction, it's the number of ways I can get 6 girls over the number of ways I can get 6 students. And a lot of times with these questions, especially when I did all of those how many at the beginning, there's no need to reinvent the wheel. We figured out the number of ways of getting 6 girls. The number of ways of getting 6 girls is 7. And we figured out the number of ways of getting 6 students. The numbers of ways of getting 6 students is 924. The only issue would be, is that fraction reducible? And the only way that fraction would be reducible is if I can divide 924 by 7. And I believe that is possible. 924 divided by 7 would be 132. And so that probability is 1 in 132. For 6 boys, it's the number of ways I can get 6 boys over the number of ways I can get 6 students. And if you want to be rigorous, the number of ways I can get 6 students, my sample space is that 924. We said there was no way of getting 6 boys. So if you wanted to, you could cut to the chase and just tell me here that the answer is 0 because it's not possible. And so if you know that something's not possible, you can show that work if you want to, but you can just acknowledge the fact that it's not possible, and therefore the probability must be 0. So now the probability that we have 4 girls and 2 boys, it's the number of ways I can get 4 girls and 2 boys. Is that too much abbreviation, or can you guys read that as 4 girls and 2 boys?
Okay.
Number of ways I can get 6 students. That's my denominator we figured out already, my entire sample space. 4 girls and 2 boys we already figured out to be 350. And I think that's reducible. We can divide both numbers by 7 because we divided the denominator by 7 already. And now they're both even, so I can divide them by 2. And dividing by 2, I get 25 over 66. And so that would be my reduced form. I'm not sure. I'm going to play with my calculator for a minute. Does anybody want to play calculator or not? With my calculator, I'm going to go 350. Then I'm going to press my fraction key, 990. And when I hit equals, yeah, it reduces it for you. Do you guys know how to put a fraction like that in your calculator and get that? Ooh, it's because I typed it in wrong. Let me try that again. 350. It wasn't over 990, was it? It was over 924. Do you guys know how to get your calculator to reduce a fraction for you?
You were saying earlier was the second button and then the PRB button, right?
If you've got a decimal, if you want to put it in as a fraction, it should just reduce it for you. And the way you put it in as a fraction is below the PRB button, there's that ABC button.
Yes.
So type 350, then hit the ABC button, then hit the 4. And what you get is 350 with a funny looking kind of squared off thing in between,
Uh-huh.
then the 924. That's the way the calculator inputs a fraction. And if you hit enter, it gives you the reduced fraction.
Okay.
Okay? Is that first side of that sheet all right? Is everybody all right with the difference between the permutation question and the combination question?
How do you reduce the fraction again?
With the calculator?
Yeah.
Okay, if you hit the same calculator as mine, you're going to type in the numerator 350. And then below the probability button, there's a button ABC. It looks like a mixed number, right? A is the whole number part and the B is over C. Press that button, then press your denominator, 924. Then if you hit equal, you should get your reduced fraction.
I got lost. I have
Okay.
I have a graphing calculator.
Okay, if you have a graphing calculator, you're going to type in 350 divided by 924. Then you're going to press math. And I think in the math menu, the first thing that comes up is arrow FRACT or something like that.
Yeah.
Pick that, and then hit enter.
Oh, okay.
Okay.
That worked. Thank you.
Yeah. You got confused because the directions I gave you was initially was for a different calculator. Okay. Poker hand contains 5 cards. You are dealt a hand. There's my other typo. I knew there was another one in here. Find okay, this is probability. Each of these are probabilities. So each of these answers will be fractions. And so in order to get those fractions, we have to do some counting. Over here, it says, what's the probability that you get all red cards? Well, that would be the number of ways you can get 5 red cards over the number of ways you can get 5 cards. And now we have to make some decisions. How are we going to count the number of ways, first of all, that I can get 5 cards? In order to determine the number of ways I can get 5 cards from a deck, first of all, are each of the cards different in the deck? Yeah? Am I going to get the same card twice from a deck? No. And now the other question is, does order matter? When I'm playing this game of cards and I get dealt my cards and I pick it up to look at my hand, when I look at that hand, did it matter to me which card came first, or does it just matter what cards I have? Does order matter? Order does not matter. And so usually cards are going to be combinations. And so my denominator, the number of ways I can pick 6 cards, I'm choosing 6. From the whole deck, I have 52 to pick from. For the numerator, cards are usually combinations. Did I give you guys my Sesame Street version of this? What helps me remember sometimes is I picture Cookie Monster singing C is for cookie, and I go C is for combinations, C is for cards, C is for committees. Cards and committees are usually combinations. And then I want it, why did I put a 6 there? I don't want 6 cards, I want 5. Sorry about that. And now I'm picking 5 cards, and if I just want red cards, well, half the deck is red, so that would be 26 combination 5. These are both going to be pretty big numbers. In the numerator, when I take 26 combination 5, I get 6, 5, 7, 8, 0. In the denominator, when I take 52 combination 5, I get 2598960. And so there we go. That one all right? If so, the next one's still a probability. It's still going to be combinations. I want the number of ways I can get 5 cards. And in my numerator, I want the number of ways I can get 5 queens. All right. Is everybody vaguely familiar with the deck of cards?
Kinda.
Kind of. Can you get 5 queens?
I don't know.
No, you only
No.
can get 4.
You can only get 4. The Queen of Hearts, Queen of Diamonds, Queen of Clubs, Queen of Spades. So this is not possible. But my answer isn't not possible. If it's not possible, what's my probability?
0.
0. Last one's probably the most involved here. My denominator, again, is the number of ways I can get 5 cards. And so that denominator is going to be my 52C5. And so that denominator is going to be my 2598960, which, thinking about it, there's like over 2.5 million different hands you can get from a deck of cards when order does not matter. How crazy is that? Now, in the numerator, I want the number of ways I can get 4 kings and 1 ace. Uh-oh, that magic word "and" is in there. Doesn't "and" tell me that I'm probably going to have to multiply 2 things? So I'm thinking "and" tells me to multiply. So I'm probably going to need to find a combination for the kings and a combination for the aces. I want to pick 4 kings. That's how many I want. How many are there in the deck to pick from?
52.
4. Then there are 52 cards, but
Yeah.
I only want
Okay.
kings.
I'm
If
sorry.
I'm only looking at the kings, there's only 4. All right. And no, thank you for saying that, because I appreciate your questions and suggestions, because sometimes it's good to clear the air, because those are things that I frequently see. You all right? We're only looking at kings, so I only have 4 to pick from.
Yes.
Yeah.
Okay. And so then for aces, I only want 1 ace. And how many aces are there to pick from?
4.
4. And so 4C4 is 1. 4C1 is 4. So when I multiply, that answer is 4. So of the over 2.5 million, only 4 fit this description. Is that very likely to occur?
No.
No, it isn't at all. That's why if you can get a hand like that, 4 kings and 1 ace, you're probably going to win some big money somewhere, right? It's not real likely. Next one. Well, I'm sorry. I'm on a roll, and I don't see you. And so I can't see your faces to see if this went well. Is this question all right for everybody?
For now.
Yes.
If
Good.
Now.
I try to do it on my own, I'll probably have questions, I think.
Okay, well, that's what the Help Me Solve It and the Ask My instructor is for. But right now, if what we did makes sense, that's what I'm looking for. Card questions occur somewhat frequently, so you will probably see a couple of card questions in this chapter test, and you will probably also see a couple of card questions on a quiz. Well, 1 card question on a quiz, probably a 2-question quiz, probably next week, sometime in between Tuesday and Thursday. So then let's go to question number 4. Question number 4 says a 3-digit number can be made from the digits 1, 2, 3, 4, 5 No digit can be repeated. Okay, so they're different numbers. I can't repeat. And I want to find the probability. So probability tells me each of these answers should be a fraction. And first I want an even number. So that's the number of ways I can get an even over the number of ways I can get a number. But now what we have to decide is, does order matter?
Yes.
Yeah, when you look at a 3-digit number, thank you for saying that so quickly. When you look at a 3-digit number, order matters. If I think 132, that's a whole lot different than 231, right? Order matters, so it's permutations. Now, with questions like this, when order matters and it's permutations, these are the ones like that baseball one where I personally think filling in the blanks is the way to go. So for my sample space, first digit I have 5 to pick from, then 4, then 3. Everybody all right with that part? Now I want to ask you, how can you tell if a number is even or not? Here I've got 132 and 231. I crossed them out too soon. One of them's even, one of them isn't, right? Which one's the even one?
132.
132. And what makes it even is just that very last digit has to be even, right? And
Yeah.
so let's look at our list. How many even numbers are there to pick from?
2.
2. And so is everybody all right? I think of if it's got to be even, that last number has to be even, and I have 2 evens to pick from. And while there's 2 evens to pick from, I'm only going to use one of them. So for digits, I have 4 to choose, and then 3. And so that gives me 2 out of 5. And so for the numbers of the probability that I get an odd, probability again is a fraction. The denominator is the sample space. 5 choices for the first digit, then 4, then 3. That's my 5 permutation 3. This time, when I fill in the spaces, if I want it to be odd, this last digit has to be odd. And how many odd numbers do I have to pick from? 3. After I use up one of the odd numbers, I still have 4 digits left, and then 3. And so when I reduce, this gives me 3 out of 5.
I'm kind of confused.
Okay. I'm going to look at that 1, 2, 3, 4, 5. Those are my digits to pick from, right?
Yes.
Now, are you all right with the denominator being 5 times 4 times 3? For the first one, I have 5 to pick from. I use one up. Then I have 4 to pick from. I use one up. Then I have 3 to pick from. Is the denominator all right?
Yes, and it only goes to 3 because there's only
Because I'm only
3
making it
odd numbers, right?
Now, it only goes to 3. All of these only go to 3 because I'm making a 3-digit number.
Oh, okay. Yes, yes.
Okay. Now, if it has to be odd, I have 3 odd numbers. And so in this last position, it can either be the 1, the 3, or the 5. So I have 3 to pick from. I'm only using up one of the odd numbers, though. So then when I fill in the rest of the blanks, I still have 4 numbers to pick from and then 3 numbers to pick from. Does that help?
Yes.
So let's look at this divisible by 5. Sample space, I'm still doing a 3-digit number, so it's 5 times 4 times 3. I'm looking at the 1, 2, 3, 4, 5. In order to be divisible by 5, how can you tell if 5 goes into a number evenly? Then 5, 10, 15, 20, 25, 30. Isn't the last digit always a 0 or a 5? And so if this has to be divisible by 5, that last digit can be 0, but 0 is not one of my choices. That last digit has to be the 5, yes? So there's only 1 5 to pick from. Once I've used up the 5, then I still have 4 digits to pick from, then 3. And so this one reduces to 1 out of 5.
Wait, why did you put the 1 at the end on the top?
Because if I look at all the numbers that can be created from those digits, 345, 415, 235. In order to be divisible by 5, doesn't that last digit have to be a 5?
Yes.
And so there's only 1 5 to put in that last space. There's only one choice of digit there.
Oh, okay.
Okay?
Yes.
The next one is a probability. I'm making a fraction. The denominator is my entire sample space, 5, 4, 3. So I'm going to recreate my list of digits here. If this number has to be bigger than 400, what type of number could it be? It could be something like 412, right? 453. It could be a number in the 400s. Could it also be a number in the 500s?
Yes.
And so in order to be bigger than 400, that first digit has to be either the 4 or the 5.
Yes.
And so I have 2 digits to pick from. But after I pick out that first digit, I'm only using one of the 2 to fill in that spot. And so for the remaining places, I still have 4 to pick from, then 3. And so this would give me 2/5 of the numbers are greater than 400. Last one asks me to find the probability that my number is bigger than 500 and even. It's a probability. My denominator is going to be my sample space, 5 times 4 times 3. If it has to be bigger than 500, doesn't that first digit have to be the 5? And so how many choices do I have for that first digit?
1.
1 choice. Beautiful. And if it has to be, so I've used up the 5. And if it has to be even, that last digit has to be either the 2 or the 4.
Yeah.
So I have 2 choices for the last digit. I'm not using both of them up though. I'm only using one of them up. So doesn't that leave me 3 choices for the middle number?
Yes.
And so I can divide out the 3's. When I multiply, that leaves me 2 over 20. So 1/10 of the numbers are greater than 500 and also even. And again, with these, I think it's easier to use that idea of filling in the blanks as opposed to using permutations because permutation notation, because, well, like greater than 400, I guess you could say that that would be, the denominator is going to be the 5p3. The numerator, there's 2p1 times 4p2 is the way it would be written out. And at some point in time, I kind of think that, well, maybe just filling in the blanks and multiplying is the easier way to go. But if you really want to use your permutation notation again. That one, all right. If so, dun, 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 it's the candy question. Box contains 10 chocolate covered candies. They all look the same, but have different fillings. There's 5 vanilla creams, 4 chocolate creams, and 1 raspberry cream. You pick 3 chocolates from the box. Okay. When I'm picking my 3 candies from the box, grabbing 3 of them, and then I'm gonna eat them. Yum, 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 yum. When I'm taking them out of the box, does it really matter to me what order I pick them in? I don't think so. So these orders not matter. So I'm going to look at combinations. These are all probability. And so I'm going to make my sample space the number of the way the event can occur over the number of things in the sample space. I'm sorry, I said I was going to make my sample space. What I meant to say, I've got to make my probability fraction. For the number of what things in the sample space, well, we said order does not matter. There are 10 chocolates in the box, and I'm going to eat 3 of them. And so each of these denominators is going to be your 10 combination 3. Is that executive decision okay for everybody? 10C3 is 10, 9, 8 over 3, 2, 1. And so I think that gives me 120. Great if you picture me, trust me doing it in the air like that. Is that what you guys are getting? Now, if I want 3 vanilla cream, we've decided it's combinations. I want 3 of them. How many vanilla cream do I have to pick from?
5.
5. That's 5 combination 3. So 5 combination 3, 5 combination 2, so that's 20 over 2, so that's 10. So this would be 10 over 120, or 1 in 12. Instead, I want 3 chocolate cream. Can somebody tell me what you think I ought to be putting in the numerator of that fraction?
4, 3.
4 combination 3, I like it. And 4 combination 3, I believe, turns out to be the number 4. So that would be 1 in 30 when I reduce. All right. Does anybody else really like chocolate covered raspberry stuff? Like that is the bomb. So I really want 3 chocolate covered raspberry candies. Can I get 3 chocolate covered raspberry candies?
No.
Why not?
This is only 1.
There's only 1 in the box. This isn't going to happen. So this is not possible. And so if it's not possible, what's the probability?
0.
Right. And those are supposed to be kind of like if you golf a gimme, like a easy shot. It's, you know, if something's not possible, probability will be 0. Don't overthink it. This last one, if I want one of each filling, what does it mean to have one of each?
Counting?
Wouldn't I have to have beautiful accounting principle? Wouldn't I have to have one chocolate and one vanilla and one raspberry out of the 10 chocolates?
Want to be a three combination three?
But I like the three for I like the combinations. For the chocolates, I want one. How many are there to pick from for the chocolate filled?
Oh, four.
4. And means multiply. Thank you, whoever said counting principle before. I want one vanilla. How many vanillas are there to pick from?
Five.
And I want one raspberry. How many raspberries are there to pick?
One.
And in the denominator, I'm picking 3 out of the 10. And so I think that turns out to be 20 over 120, which is and so that, excuse me. You know, that I felt that, I'm sorry, I apologize. I felt that allergy season sneeze coming. And I didn't want to sneeze into your ears. And then, of course, the sneeze didn't come. Sorry about that. So this idea of do I use a permutation or a combination? I think probably the most thought-provoking part is deciding which to use. And again, it's kind of based on the idea, does order matter? If you're making several decisions, realize the word and, that's where you're going to pull out your counting principle and multiply. If order does not matter, it's your combinations. If order does matter, it's your permutations. Sometimes they're pretty straightforward and you can just use your permutation on the calculator. But a lot of times I find that those permutations are easier where I picture putting the things in the line and filling in blanks. All right. Okay, I'm looking. We have about 10 minutes left. Part of me really, 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 really wants to look at not, and part of me doesn't, as much as I want to get through the content, I don't want to throw too much at you guys in one class. Are you up to one more idea or not? The not or odds homework is due on Thursday. We can leave the whole section on Tuesday, which will give you 2 days to turn around for the homework. I don't think there's anything that is that challenging in it. Or we can start looking at the not or odds today.
It's up to you.
We'll just add not. So I'm going to add a page, and I'm going to look at not. I don't think this one's too challenging at all. We're looking at the probability of an event not occurring. And to look at the probability of an event not occurring, I want to start with an example. With my example, I'm going to roll it down. What's the probability that I roll 4?
1 out of 6.
Beautiful. Are we all in agreement? 6 numbers on a die. One of them is a 4. So then what's the probability that I don't get a 4? There's 6 numbers on a die. How many of those numbers are not 4?
5.
So that's 5 out of 6. And if I look at those two answers, 1/6 plus 5/6 is 6/6 or 1. Another example, let's say I have a deck of cards. I pick one. What's the probability that I get a queen? 52 cards in the deck. How many of them are queen? 4 out of 52. So what's the probability that I don't get a queen? If there are 4 queens, how many of the 52 cards are not?
48.
48. And do you notice when I compare these two, 4 out of 52 plus 48 out of 52 would give me 52 out of 52 or 1. And those are considered complementary events. Combined, they make up the same samples, the entire sample space. But they have nothing in common. And so if E is an event, E prime is its complement. Ooh, E prime is a complement. Does that bring back for anybody fond memories of our study of sets? And so if my universal set is my sample space, and this is my event, that would be its complement. Like, for example, if this was my die, and my event is getting the number 4, the complement is 1, 2, 3, 5, 6. Idea all right?
Yeah.
And because they combine to give me the whole sample space, I know that the probability of the event plus the probability of its complement, like those 2 examples above, will always equal to 1. And so doing a little bit of algebra on that, we get the probability of the complement to be 1 minus the probability of the event, or the probability of something not occurring is equal to 1 minus the probability that it does occur. And so I am pulling up my phone for just a second. I'm looking at my weather app, and it says that, you know, around 1 o'clock we want to go to the zoo because my daughter wants to take her son to the zoo. And so I'm looking at it, and it says the probability of rain at 1 o'clock is 3%, which is 0.03. What's the probability that it's going to not rain? I see that word not, and I think, all right, well, if there's a 3% chance of rain, 0.03, the chance of it not raining is 1 minus that, or 0.97, or 97%. Does that make sense? If there's a 3% chance of rain, then The rest of the time, it's not going to rain, so it'll be a 97% chance.
Huh.
Do you guys usually do that when you look at the weather report? The weather report always tells you the chance of rain. So like my husband will look at the weather and they'll show like drops, raindrops, and say there's a 30% chance of rain. And he's like, oh, we can't do that. It might rain. And I look at him and say, there's a 30% chance of rain. That means there's a 70% chance it's not going to rain. We're going to go. So, but you guys do that in your head? And you're like, weather guys always talk about the chance of rain. I always think, no, I want to see the sunny side.
Right.
So, let's, one more card example. Let's say you have a deck of cards. What's the probability? I pick one. What's the probability that it's not a heart? And we're doing hearts because that's the easiest one to draw. Well, I see that word not. And a lot of times when you're trying to find the probability of something not happening, it's easier actually to find the probability that it does happen. And then we're going to subtract from 1. So that's 1 minus the probability of a heart. And in my deck, there are 13 out of 52 that are hearts. That we have a common denominator. 52 out of 52 minus 13 out of 52 gives me 39 out of 52. Or 3/4. And the not is the idea that to find the probability of something not occurring, we'll find the probability that it does occur and then subtract from 1. Doable?
Yeah.
Yeah. Of that, the 2 homeworks that are due next week, Thursday, one is got 10 questions in it. And while that's a small number of questions for these assignments, they're thought-provoking like that worksheet we just did. The other involves not, but it also involves or and odds. So right now we've gone over the rules for not. We have not gone over the rules for or odds yet. So take it with a grain of salt. It's a holiday weekend coming up. Yay. So everybody have a nice long weekend. Everybody enjoy.